Good evening, children. Good evening. Good evening, online students.
Good
Good
evening,
evening.
ma'am.
Good evening.
Good evening, ma'am.
Good evening. I've shared my screen. Visible, right?
Yes, ma'am.
Okay. Okay. All right. We're not going to write anything today. Just listen. I'll share the presentation. See this one. In the figure, angle B is 90 degrees. In this figure here, angle B is 90 degrees. C is the midpoint of BD. C is the midpoint of BD. BD is equal to A. BD is equal to A. And if this is the midpoint, then this will be A by 2. This will be A by 2. Because BD is A and C is the midpoint. So this is going to be A by 2 and this one A by 2. Angle BAC is theta. BAC, this one is theta. This one is theta degrees. This is theta. And AD is B. AD, this is B. Find sine theta and cos theta. Find sine theta and cos theta. So this is the question figure. This is the question figure. So I've marked everything here. Whatever is given, AD is given to be B units. I've marked here. And A by 2 here. See, this one is A by 2. This one is A by 2. Correct? All right. So we need to find, this is theta because it's given here. Angle BAC is theta. BAC, this one is theta. This is theta. We need to find sine theta and cos theta. We need to find sine theta and cos theta. And what is sine theta? Let's go here. Yeah. See here. What is sine theta? Sine theta is equal to opposite by hypotenuse. So first, theta is an angle in triangle ABC. Theta is an angle in this triangle, right triangle ABC. So opposite BC by hypotenuse AC. BC by AC. Theta is an angle in this small right triangle. So opposite by hypotenuse. And then cos theta adjacent AB by hypotenuse AC. Cos theta is adjacent. This is the adjacent side by the hypotenuse. It's not this hypotenuse because theta is here. This is the triangle. This one is theta. And this is C, this is B, this is A. This one is A by 2. Yeah. Correct? Okay, so you have the ratios here. Cos theta and sin theta. So now for cos theta, so for sin theta is opposite A by 2 we have, but we don't know the hypotenuse. We have to find the hypotenuse. And for cos theta, AB, adjacent AB by hypotenuse, again, we don't know AB. So we need to find both AB and AC. Then once you find AB and AC, you can answer the questions, sin theta and cos theta. So that's what we have done here. So to find AD, we have to use the whole right triangle ABD. To find AD, we have to use the whole right triangle ABD. Correct? Oh, not AD, sorry. AD is given, no? Sorry. AD is given. We have to find what? AB and AC. No, actually, those guys are noisy, no, so I'm really distracted. I'm very sorry. This we have to find AC and AB. I'll correct myself. We have to find AC and AB. AB we'll find using the whole right triangle. AB we'll find using the whole right triangle ABD. Because you know that this is A and this one is B. So you can find AB. And once you find AB in this small right triangle, you know AB and you know this one BC. And you can find this one using Pythagoras theorem. We have to find this one and this one. This one we'll find using the whole right triangle because BD is known, AD is known. Pythagoras theorem, you can find AB. After finding this one, take the small right triangle. We have found this now. Now using this one and Pythagoras theorem, you can find AC in a small right triangle. So that's what I've worked here. And then you can find the ratios. All right. Okay, let me see if you can do it. Do it, children. Work this now. Work this, take down the question and do this. Let me see if you're getting the results correctly using Pythagoras theorem. Children, take down this question and try it now. Done, children? Yeah. Online students completed? Tanya, Rakshita, Rishmi, Ranjan,
Working, ma'am.
Florentina.
I'm working.
How much is BC, children? How much is BC? A by 2. And how much is CD? A by 2. And do we know anything else? AD, B. Now, what are you going to find first? AB, AB. You're going to find AB. Then after finding AB, you will find AC. How much is AB? Root of B square minus A square. Arjun? Arjun? Two A square plus? You got that. What about you, Madhumita? That's because square root of B square minus A square, you've taken it out as B minus A. No. B square minus A, when there's a plus or a minus in the middle, see, root of B square into A square. Root of B square into A square is BA. But root of B square minus A square is the same. When there's a plus or a minus, this is considered as a whole. You cannot find the individual square roots. You can find the individual square roots only when the connecting sign is multiplication. So it's not there. So let's see what it is. What would be AB? Yeah, AB is root of B square minus A square. Because the whole thing is A, right? The whole thing is A. This one is B. Pythagoras theorem, children. AB square plus BD square is equal to AD square. AB square plus BD square is equal to AD square. AB square we don't know. Plus BD square is A square is equal to AD square, B square. So AB square is equal to B square minus A square. So AB is equal to square root of B square minus A square. Correct? Where did we go wrong, Arjun? You took A by 2 for something? Oh, okay, you understand now? This whole thing is A. For what did you say actually? Okay, A by 2 plus A by 2 the whole square. A by 2 plus A by 2 is A, no? 2A by 2, 2 and 2 will cancel. 2A by 2, 2 and 2 will cancel. Oh, so you said 4A square by 4, huh? 4 and 4 will cancel. You got root of B square. Okay. Got it now? Understood? Okay. And next we'll have to find. Next we'll have to find AC. AC. Having found this is root of B square minus A square. And this one is A by 2. Now we'll have to find AC. So see here AC is equal to square root of AB square plus BC square. See, you must know Pythagoras theorem. AC is equal to square root of AB square plus BC square. Substituted. And how, when you square this one, the square root is eliminated. When you square this, see children, AC is equal to square root of AB square plus BC square, Pythagoras theorem. Then that is equal to square root of, substitute the values. Now the square and the square root is eliminated. So you will get square root of B square minus A square plus A square by 4. Common denominator. Then minus 4A square plus A square is minus 3A square. So it will be the square root of the numerator divided by square root of 4 is 2. So 2 is out of the square root, you can see. 2 is out of the square root because square root of 4 is 2. Now you should fill BC and AC, find sine theta and cos theta. So you can see I've used this representation divided by. This is BC divided by AC. Then I take multiplication and reciprocal. 2 and 2 cancels, and this is sine theta. And for cos theta, yeah, you can rationalize it. When it's lengthy, you see your marks. If it's 4 marks, you have to rationalize it. AB, this is AB divided by BC. Then it will become into and reciprocal. So 2, this into this divided by root of 4 BC4 minus 3 is over. Correct. All of you write on fast. Complete it. If you've gone wrong, correct it and complete the answer. Done? Done, children? Online students completed?
Yes, ma'am.
Yes, ma'am.
Okay. See. Sorry? Yeah, sure. Finished? Sorry, yeah, you finished. Madhumita, finished? Okay. Yeah. Yeah. So look at this one. No, after this, we are not writing anything. That I just wanted to check if you can get Pythagoras theorem correctly, but I can see some of you still struggling with that. So you've realized where you're not so good, so please work on that. It's easy. So what you need to understand is root of, like a square minus b square is a whole. A square minus b square is a whole. This is not square root of a square is a minus square root of b square is b. It's not that. See, you can take an example to understand that. Now, how will you work 16 minus 9? Root of 16 minus 9. What is it? Is it 4 minus 3, 1? If it is 1, then it should be the square root of 1 here. If your answer is 1, then it should have been square root of 1. Then only you can get 1 as the answer, right? I'll tell you again. See, square root of 16 minus 9. Supposing square root of 16 is 4. Square root of 9 is 3. 4 minus 3 is 1. If this is the result for this one, then that means the value of this is 1, because only square root of 1 is 1. But this is not, this is root of 16 minus 9, which is nowhere 1. So how do you work this? Root of 16 minus 9. So you should subtract 16 minus 9. 7. This is root 7. This is root 7, whose value is 2 point something. It's not 1. But if it was root of 16 into 9, then you can do it. Root of 16 is square root of 16 is 4. This is 3 and 12. Because even if you multiply, you will get the same thing. 16 into 9 is 144, and square root of 144 is 12. Either way, you'll get the same answer. That means, but this one, see, you understand when I say that? Yeah. So when it's plus or minus, it's one whole thing. Okay, in this figure, AC minus AB. AC minus AB. The difference between these two sides is 1 centimeter. AC minus AB is equal to 1 centimeter. So that means what? AC is equal to 1 plus AB. Or you can write AB is equal to AC minus 1. AC minus 1. You can take any one of the two versions. Given that AC minus AB is equal to 1, you can either choose to write AC is equal to AB plus 1 or 1 plus AB. Or you can write AB is equal to AC minus 1. You can write AC is equal to AB plus 1. Or you can write AB is equal to AC minus 1. Okay, so go with one of the two. Not both, one of the two. Supposing you go with the first one, this one. So AC is equal to AB plus 1. What is AC? AC is AB plus 1. AC is AB plus 1. So AC is AC only. AC is AC. Sorry. Of confusion. Sorry. No, I just blabbered something. I'm sorry, children. I'm sorry. AB is AB. AC is AB plus 1. BC is 5. BC is 5. AB is AB only. AC is AB plus 1 and BC is 5. Now, how will you connect all these three using Pythagoras theorem? AB the whole square plus 5 square is equal to AB plus 1 the whole square. So you all agree that when you work this, you can find the value of AB. When you work this, you will find the value of AB. And once you find AB, AB plus 1. Once you find AB, you will find this side as well as AC. So you will know all the three sides of the right triangle. And then you can answer this question. Correct? Or what can you do? You can take or if you take this AB is AC minus 1. AB is what? What is this AB? AB is AC minus 1. If you take AB as AC minus 1, then AC is AC only. AC is AC. AB is AC minus 1. And BC is 5. So then it will be AC minus 1 the whole square plus phi square is equal to AC square. Pythagoras theorem. AB square is AC minus 1 the whole square plus phi square is equal to AC square. So here when you work, you will get AC. And once you find AC, you can find AB, which is AC minus 1. So that's what you have to do. So what have I done? AC minus AB is given to be 1. So I have written AC is equal to AB plus 1. I have done it like this, which means I'm taking AB as AB and AC as AB plus 1. AC is AB plus 1. AB is AB only. This is AB plus 1 and this is 5. So now by Pythagoras theorem, AC square is equal to AB square plus BC square. Substitute. AC is AB plus 1, the whole square, is equal to AB square plus BC square, which is 5 square. So you can see that throughout the unknown is only AB. Throughout the unknown is AB. So you'll work and find AB and yeah, then you can finish it. Now when you expand this, be careful. AB plus 1 the whole square is like A plus B the whole square. A square 2AB B square. Yeah, then you have to evaluate 1 plus sine C by 1 plus cos C. Sine C meaning you should work at the ratio for this angle. For this angle, sine C, this angle. Sine C is opposite AB by hypotenuse AC. Cos C, adjacent BC by hypotenuse AC. So substitute the values and calculate. Got this, children? Online students? Any questions here?
No doubts, ma'am.
This is similar. Okay, this is similar. Right triangle ABC, right angled at B. Right triangle ABC, right angled at B. AB is 21 and BC plus AC is equal to 49. So you can take any one of the two. Either you can take BC is equal to 49 minus AC, or you can take AC is equal to 49 minus BC. Any one of the two. Don't change both. So supposing you don't want this, you want this one. Okay, then instead of BC, what will you write? 49 minus AC. Instead of BC, you should write 49 minus AC. AC is AC only. AC is AC. BC is 49 minus AC. And this AB is 21. Now connect the three sides using Pythagoras theorem. Or what's the other one if you want to use this? If you don't want this, you want this, then yeah, AC is 49 minus BC. What about BC? Let BC remain BC. Then BC be BC. AC is 49 minus BC and AB is 21. So now the only unknown is BC. When you connect the three sides using Pythagoras theorem, the only unknown is BC. So you can work and find BC. Yeah. When you know all the three sides, you can see this is sine A and secant C. You should find sine A. Sine A for this angle, this is the opposite side and hypotenuse. Secant C for this angle, secant C is hypotenuse by adjacent. Secant C, this is C. Secant C is hypotenuse AC by adjacent. For this one, the adjacent side is BC. For angle C, the adjacent side is BC. See, when they say secant C, you must take the opposite side, adjacent side with respect to angle C. When they say sine A, you must take the opposite side, adjacent side with respect to angle A. So secant C, this one is C. Secant C is hypotenuse by adjacent. So hypotenuse is AC, adjacent is BC. For angle C, this is the adjacent side, BC. Okay. So here we have phi tan alpha is equal to 4. So what is tan alpha? 4/5. Okay. Now, one method is use this in a right triangle. Use this in a right triangle. Mark this alpha. What is tan alpha? Opposite by adjacent. So opposite by adjacent. Correct? Opposite by adjacent. And then find the hypotenuse. So it will be 16 plus 25. What is 16 plus 25? 41. So this is going to be square root of 41. Now what is sine alpha? What is sine alpha? Opposite by hypotenuse. 4 by root 41. What is cos alpha? 5 by root 41. So find that and fill it and evaluate. Whenever you have a ratio, tan alpha is equal to 4/5. Whenever you have a ratio, take a right triangle, fill the two sides, because from the ratio you can fill two sides. Fill the two sides, find the third side using Pythagoras theorem. Now that you have all the three sides, you can find the other t ratios. Sine alpha, cos alpha, you can find all that from the triangle, substitute and evaluate. That's one method. Otherwise, what you can do is, without using a right triangle, 5 tan alpha is equal to 4. So tan alpha is equal to 4/5. Now, in the expression, we have sine and cos alpha. How do you convert all that to tan alpha? When you divide the numerator and denominator by cos, you can also divide by sine. We'll come to that later. Divide both the numerator and denominator by cos. So what will happen? 5 sine alpha by cos alpha minus 3 cos alpha by cos alpha divided by 5 sine alpha by cos alpha plus 2 cos alpha by cos alpha. Yeah. You can write tan alpha sine alpha by cos alpha and substitute directly also. Yeah. Okay. Okay, you can do that also. Yeah, you can do that also. Yeah. So, children, yeah. So now what is 5 sine alpha by cos alpha? 5 tan alpha minus 3 divided by 5 tan alpha plus 2. Now substitute. Tan alpha we know is 4/5. So substitute 4/5 here, 4/5 here. Yeah. Yeah, that part you know. So you can do this. You can also divide by sine. Okay. Okay, now you can also divide by sine. So what is 5 sine alpha by sine alpha? 5 minus 3 cos alpha by sine alpha. No, 3 cot alpha. Okay, 1 by tan. We are now dividing by, online students, we are now dividing the numerator and denominator by sine alpha. 5 sine alpha by sine alpha minus 3 cos alpha by sine alpha divided by 5 sine alpha by sine alpha plus 2 cos alpha by sine alpha. So this one becomes 5 minus 3 cot alpha divided by 5 plus 2 cot alpha. If tan alpha is 4/5, cot alpha is 5/4. 5/4. That's all. If tan alpha is 4/5, cot alpha is 5/4. So you can substitute 5/4 here and the value. So like this, even without using the right triangle, you can convert the ratios in the expression to the given ratio. You can convert the ratios in the expression to the given ratio tan alpha by dividing the numerator and denominator by either sine or cos. Anything will give you the result. Is that fine? So I've done one of it here. I've divided by cos alpha. I've divided by cos. So I got tan. Then I substituted 4/5 and yeah. Online children? Can we proceed? Online students?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
All right. All right. Same thing here. cot A is equal to 12 by 16. Cot A is equal to 12 by 16. You can simplify. Sometimes we have a doubt because when we use Pythagoras theorem with 12 and 16, you'll get 20. But when you use Pythagoras theorem with 3 and 4, you'll get 5. So we'll be worried like if I use a triangle, if I'll get different ratios. The ratio will be the same. Final ratio will be the same. You can simplify. You can simplify this. 3s or 4s are. Even if you don't simplify, supposing you don't notice it, you don't simplify, still you'll get the same answer. Maybe if you didn't simplify at all, after once you simplify, you'll get the simplest form answer, the correct answer. So don't worry about that. You can simplify. So same thing, dividing the numerator and denominator by sine or cos will give you the result. Don't use a right triangle. Why is that lengthy procedure? You can directly divide. You can use a triangle. See, it all depends on your writing speed now. You can use a right triangle, or you can divide the numerator and denominator by. Even if you show all the required steps and do it in 3 steps, you will get full marks. Yeah, I think I've done it and you understand. Okay, alternates and 3 methods I've done. But so far, I've not seen any specific question like that. Even in the board exam, I've not seen any specific question like that. No. So I've divided by sine. Then in the next one, I've divided by cos. And in the next one, I've used the right triangle. In the last, see, this is one solution, alternate solution, alternate solution. So in the first one, I've divided by sine. Then next one by cos. Next one, I've used the right triangle. All right. Raj, why should we use using the right triangle? What ratios will you find? Using the right triangle, what ratios will you find? Fine. Using the right triangle, what ratios will you find? Using the right triangle, what ratios will you find? All the ratios. Huh? For this question, Sashank, for this one. Why will you find all the ratios for this? Yes, Dilipan? Yeah. Okay. Okay. So he's answered the general question and a specific question. He's telling using a right triangle, we can find all the T ratios. But if to answer this question, it's enough if you find sine and cos A. Very safe answer. Very good. Yeah. As Arjun also said, if you use a right triangle, find only sine and cos A. Don't find all the ratios. You don't need all that. If you use the right triangle, don't find all the T ratios, all the other T ratios. Use the right triangle and find only sine A and cos A. Because that's what you have to substitute here to evaluate. Find only sine and cos A. Okay. Yeah. So this one, divide the numerator and denominator. Divide the numerator and denominator by cos theta. And we'll see what. Okay, first I should tell you why by cos theta. Now, when you compare both the sides here, you have 1 and root 3 here. So you want to, like you go down to 9th standard, the first chapter, number systems, and that part rationalization. We compare the LHS and RHS, no? To supposing something is given is equal to A plus B root 5. Then we compare both the sides and we say A is equal to this and B is equal to this. We compare the two sides. Okay. So like that here we're going to compare to find theta. One of the methods is like this, is to compare both the sides. When you compare the two sides, the LHS and RHS, this is cos theta, but here you have 1. See, for cos theta, you have 1. See, like cos theta, 1, 1. Minus, plus, minus, plus. Sin theta, root 3, root 3. Like both the sides are matching. Like matching, right? So what we want to do is, this is 1 here, right? We want to make this also 1 so that we can compare both the sides. Because everything matches. So we want to make this one also 1, 1. So that both the sides match. So for that, what you have to do, you'll have to divide by cos theta only. So cos theta by cos theta minus plus sin theta by cos theta. So it will be 1 minus tan theta divided by 1 plus tan theta. என்ன சொல்றான்? Online students, just give me a minute, just a minute. Yeah, thank you, children. So now what do we have here is equal to 1 minus root 3 by 1 plus root 3, correct? Now compare both the sides here. 1, 1 minus 1, 1 plus plus. So that means tan theta is equal to root 3. That means tan theta is equal to root 3. Here also see tan theta is equal to root 3. So on comparing both the sides, tan theta is equal to root 3 and tan theta is equal to tan 60 degrees. Root 3 is tan 60 degrees. So again comparing both the sides, theta is 60 degrees. Theta is 60 degrees. Okay, so this is one version. Sometimes sometimes in school teachers do it like this also. So I've done both. This is the easiest and this is enough actually. This is enough to find theta. So sometimes, you know, they want an elaborate thing like this. So I can't justify which is correct and all that. The first method is enough. This method is enough actually. Now here we do the same thing. We do the same thing till here. The same thing, see here till here. Actually, at this step, we compare. We compare tan theta is equal to root 3. So tan theta is equal to tan 60 degrees, theta is equal to 60, and we finished the answer. You can also proceed like this. You can also proceed like this by cross multiplying. By cross multiplying. And finding theta, not like this by comparing both the sides, but finding theta. So you can cross multiply. And see, you get 1 minus tan theta into 1 plus root 3 is equal to, can you see that, of cross multiply? So now it's like multiplying. What is this? 1 plus root 3 into 1 is 1 plus root 3. Then 1 plus root 3 into this one. So minus tan theta into 1 plus root 3. Multiplying. Multiply this one as a whole. 1 plus root 3 into 1 is 1 plus root 3. 1 plus root 3 into minus tan theta. Minus tan theta into 1 plus root 3. 1 minus root 3 into 1 is 1 minus root 3. And then minus into plus is minus. 1 minus root 3 into tan theta is tan theta into 1 minus root 3. Now we are going to gather the numbers on one side and tan theta, that on the other side. Now we're going to gather the numbers on one side and those terms which have tan theta on the other side. So there are 4 terms here. 1, this is 2, this is 3, this is 4. There are 4 terms. Okay, so this tan theta and tan theta, I've got it to the RHS. Anywhere you can take it. So here you can see it in the RHS, and this one and this one, you can see it in the LHS. Of course, the signs will change. When you transpose, the signs will change. I've written this as it is, and this one moves. So you can see the minus sign. And here this one moves. So you can see this minus tan theta becomes plus tan theta. So after transposing and opening the bracket, okay, you see this bracket, I've opened the bracket. So minus into minus is plus. This one is plus. So this gets cancelled. √3 plus 2, √3 is 2 √3. And here tan theta is common. Tan theta is common. See, you can also multiply everything, children. Like you can also do 1 into 1, 1 into tan theta. Like that also you can do. You do it in your, not that you should. See, you can like treat this as 2 terms. 2 terms here and 2 terms here, no? You can multiply like this also. 1 into 1, 1. 1 into minus tan theta, minus tan theta. √3 into 1, √3. √3 into minus tan theta, minus √3 tan theta. That also you do. Then same thing. Then you should take all the tan thetas to the other side and numbers to one side. So you please do it the way you want to multiply. Okay, so now I have taken tan theta common here. Tan theta common here. See this tan theta. Tan theta is, see, you cannot, supposing you had tan 45 degrees. Supposing you have tan 45 degrees plus tan 60 degrees. Then you cannot take tan common and write 45 plus 60. Because tan 45 is one thing. It's not separable. Tan 45 is, they're stuck to one another. You cannot take out 45 from that. Here also tan 60 is one thing. Tan 60 is not tan into 60. But this one is different. This one is tan theta is here. And into 1 minus √3. Tan theta, 1 plus √3. So we're taking out tan theta common. Tan theta common. So you'll get this one in the bracket, this one and this one here. So this cancels. Tan theta into 2. Into 2. So now 2 and 2 will get cancelled on both the sides. I think I've got it for division. Okay, I've brought this down for division here. This 2 will come down for division, then they get cancelled. So you get tan theta is equal to √3. Tan theta is equal to √3. And then tan theta is tan 60. You can stop. If you ask me, you can stop here. You can stop here and compare both the sides. Yeah, just to be safe, we should do that. Yeah, maybe. Sometimes we don't know, because for every question, we don't know what is expected, right? For each and every question. So we normally try to be safe and do some elaborate working like this. See, if this particular sum your teacher takes up in the class, you can ask her. Otherwise, how can you go and ask the teacher? Each and every sum, you cannot ask, how to work for this one. Is this enough? Is that enough? So if you know more than one way of working, and if you feel one is more elaborate, just do the elaborate one for more marks. That's all. Correct. That's another version. See, actually, even a teacher will not be able to answer this question, because for every question, there is nothing like you should do it like this. Now, see, board is actually very relaxed. You will get marks actually. But still, after writing that, you shouldn't feel, what if I lose marks? So it's better you do this. So I can give you contradictory answers. So this one, if you're very sure, it hardly takes a little more time. You can finish it and be sure that you're getting 4 marks. Okay. And I said, like I multiplied, you don't have to do it like this. You can also do it term by term, 1 into 1, and then 1 into tan theta, √3 into 1, √3 into tan theta, like that. Then get the tan thetas on one side, numbers on the other side, like this. All right. So here also, this is very important. This actually, all this is from NCERT exemplar or, some earlier board question paper. So I've not picked sums of my choice, whatever I like. It's not like that. It's either exemplar or previous years. Huh? Yeah, okay, very important. All right. So this one once happened in the board exam. So 4 sine theta is equal to 3. So sine theta is equal to 3 by 4. Now you need to evaluate. You need to show that this one is equal to this one. Show that this is equal to this. Can you just go through that instead of me just go through this and. Or maybe we'll work this one alone. Or we'll go through. We'll go through. Yeah. Yes. Please go through and ask me if you have any questions. I'll just help you get started, okay? Cosecant square theta minus cot square theta is 1. That's what I've written 1 here. Because by the identity, cosecant square theta minus cot square theta is 1. So I've written 1 here. And secant square theta minus 1 is tan square theta. Plus 2 cot theta. But children, I'm sorry, I didn't read the question properly. If 4 sine theta is equal to 3, find x. If I just saw this in this, I thought we had to show that both the sides are equal. I've made a lot of mistakes today. I'm so sorry. I didn't read the question properly. I just saw this part. I thought we'll have to show that this is equal to this. No, I was wrong. I'm so sorry. Find x. Find x if this is equal. This is equal. This one is an equation. This one is an equation. Because see here, find x if this is equal. Not sure that this is equal to this. If 4 sine theta is equal to 3, find x. If this equation is true. Yeah, so take the equation, write the equation here. And this one is 1 by the identity. This one is tan square theta. Then plus 2 cot theta. Yeah, now you can proceed. Okay. So why is this 1? Cosecant square theta minus cot square theta is 1. And this one? Secant square theta minus 1 is tan square theta. Okay. And then square root of 1 by tan square theta. Square root of 1 is 1. Square root of tan square theta. Tan square theta means tan theta into tan theta. So 1 tan theta comes out of the square root. Then the rest as it is. The rest as it is. Next step, 1 by tan theta is cot theta. The reciprocal. 1 by tan theta can be written as cot theta. Plus 2 cot theta is equal to this one. Now these are like terms, no? 2 cot theta plus 1 cot theta is 3 cot theta. 2 cot theta plus 1 cot theta is 3 cot theta. And this one minus cos theta. We are gathering the ratios on one side is equal to root 7 by x. We're just gathering the ratios on one side. Now the thing is, see, now we have sin theta is equal to 3 by 4. Either you can draw a right triangle and find the values of cosecant square theta and and find the values of cot theta and cos theta. At this stage, you can stop, take a right triangle, and what is sin theta? 3 by 4. You can mark this one as theta, opposite by hypotenuse, and find this one. So it will be 16 minus 9, 7, root 7. This will be root 7. So then what is cot theta? Cot theta is adjacent by opposite, root 7 by 3. And cos theta is adjacent by hypotenuse, root 7 by 4. You can take the values from the right triangle. At this stage, we can stop. We need the values of cot theta and cos theta. But we only know sin theta is 3 by 4. And we know that using a right triangle and this ratio, we can find the other ratios. So you can stop here, take a right triangle, use sin theta 3 by 4 there, find the missing side, and find cot theta and cos theta using the right triangle. Mark off any acute angle as theta and find cot theta and cos theta and substitute the values. That's all you'll find x. Then cot theta will become a number and the cos theta is also a number. Then you can solve for x. That's one way. Or instead of using the right triangle, you can use algebraic. Instead of using a right triangle, you can use trigonometric identities. What is so since you have sine, you know cosecant is 4 by 3. Sin theta is 3 by 4. So that means cosecant theta is 4 by 3. So I'm just trying to introduce sine or cosecant. So what is cot theta? Square root of cosecant square theta minus cot square theta is equal to 1. So cosecant square theta minus 1 is equal to cot square theta. So cot theta is equal to square root of cosecant square theta minus 1. That's what I've written here. Similarly, cos theta, sin square theta plus cos square theta is equal to 1. So cos square theta is equal to 1 minus sin square theta. So cos theta is equal to square root of 1 minus sin square theta. So why have we replaced that? Because that way we can introduce cosecant and sine. And we have the value already. Sin theta is 3 by 4. Cosecant theta will be 4 by 3. So that's the reason. So without using the right triangle. So we can introduce cot, we can write it in terms of cosecant, cos in terms of sine. Now you know the values. Cosecant theta is 4 by 3. So cosecant square theta will be 4 by 3 the whole square. And sine square theta, 3 by 4 the whole square. After this, I think you can help yourself. Root 7 gets cancelled. That's how we have root 7 gets cancelled here. 3 3s are 3 4s are. So 3 by 4 is equal to 1 by x. So taking reciprocals on both the sides, x is equal to 4 by 3. 1 by x, or you can cross multiply. Or you can take reciprocals on both the sides. 1 by x becomes x. 3 by 4 becomes 4 by 3. Or you can cross multiply. Online students? Any questions?
Understood, ma'am.
Okay, Danya, here should we show that the LHS is equal to the RHS?
No, ma'am.
Okay. Then what's the
They are
question?
only asking to find the value of x.
Yeah, the given condition is true. The equation is true. So using the equation, we have to find the value of x. Okay. Very good. Same thing here, children. So what is 3 cos theta is equal to 5 sin theta. So 3 is equal to 5 sin theta by cos theta, correct? 3 is equal to 5 sin theta by cos theta. So 3 is equal to 5 tan theta. So what is tan theta then? 3 by 5. Now you can use a right triangle. Always remember the statement. When you have one t ratio, you can use a right triangle and find all the other t ratios. When you have one t ratio, we have one t ratio. Tan theta is equal to 3 by 5. When you use this in a right triangle, find the missing side using Pythagoras theorem. You can find all the other t ratios. So we know tan theta is 3 by 5. So you can use a right triangle and find the other ratios, sin theta, secant theta, cos, whatever you need. Substitute and evaluate. That's one way of doing it. Since there are many ways I've done, yeah, even I've used a triangle here. I've also used a triangle, so you can see. I found cot, so don't ask me why. So if you write it as cos by sin, it will be cot. So using this, I found cot theta is 5 by 3. Then I used the right triangle, Pythagoras theorem. I found all the sides. Then whatever I need here, sin theta I need, so I found sin theta. Then I need secant theta, so I found secant theta. Then I need cos theta, so cos theta. I find all the ratios and then I substitute. Okay, so this is a question to. There's a question to test your patience. Test your patience. Yes. Yeah, somebody.
Ma'am, in the first itself, can't we substitute 3 cos theta instead of 5 sin theta in the expression?
Oh, yeah, you can do that also. Very good. Yeah, you can do that. 3 cos theta, that's what. So actually, there are multiple ways of doing it. Even I looked at the slide to see how I have worked it. Here, I worked it like that. I would have told you that. If you didn't say that, I would have told you that after I finish this. That's another way. That's another way of doing. So, one second. So we know that 5 sin theta is equal to 3 cos theta. So you can go here in the expression, we have 5 sin theta, right? So instead of this, you can use 3 cos theta. Just write 3 cos theta. 3 cos theta, 3 cos theta. 3 cos theta. So 3 cos theta plus 2 cos theta becomes 5 cos theta. And 3 cos theta minus 2 cos theta becomes plus cos theta. Yeah, then you can simplify. Perfect, Rakshita. You can simplify. Sometimes when you have to evaluate, depending, I'll tell you in some other question. You can evaluate and then find the value. I'll show you. I'm coming from behind actually, so I have a question like that. I'll show you.
Okay, ma'am.
Yeah. So sometimes when we have to evaluate, you can simplify this expression. You can simplify this and then get the value. You don't have to directly, like substitute the values for sine, secant, and cos. Sometimes when simplification is possible, you can simplify and then find the value. I have a question like that. I'll show you. This is another one. Yeah, go through this, children. What are the different ways in which you can find ratios? Triangle, identities. You can use trigonometric identities or angle, using angle. Supposing it's a standard angle. If it's a standard angle, you can use a table and find the angle itself. Yeah, please go through this, children. So the idea, no, sorry, I'm disturbing you. The idea is you have two different ratios. You bring it to the same ratio, only then you can find it. If you have x and y in the equation, you cannot, one equation you have. You have only one equation, but you have two unknowns. You cannot find anything. In one equation, if you have two unknowns, you cannot find any value. But in one equation, if you have one unknown, like x or y, you can find the value of x or y. So this is one equation, 15 tan square theta plus 4 secant square theta is equal to 23 is one equation. But we have two ratios, tan theta and secant theta. So you make both tan or both secant. So you can solve it and find them. One equation, one unknown, you can find the value of that unknown. That's why we wrote tan square theta as secant square theta minus 1. So that throughout we have only secant. Or you can take away secant square theta and write it as 1 plus tan square theta. So that you have throughout tan. And you will find the value of tan. That's the idea. Yeah, you have a question? Yeah, ask me again. How will? Yeah, it can. No, sine 45 is 1 by root 2. Cos 45 is also 1 by root 2. Okay, but here you ask me. Oh, here. 1 and root 2. So it will be the same, no? When it's an isosceles right triangle. Both the opposite and adjacent side will have the same value. In that case, sine theta and cos theta will have. See, sine theta is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. If the opposite side and the adjacent side have the same value, then sine theta will be equal to cos theta. And that's possible only in an isosceles right triangle. Okay, answer this question. Can the value of sine theta, can the value of sine theta be 13 by 15? No, answers can be yes, no, can't say. The answer can be, yeah, how can you say? So answer can be yes, no, or can't say. Yeah, sine theta is equal to 13 by 15. Possible, not possible, can't say.
Possible, ma'am.
Possible. Why? How can you justify that it's possible? Correct. Very good. Because opposite by hypotenuse, we know that the hypotenuse is the. Oh, Arjun. Oh, very good. You're right. Because Sine theta is opposite by hypotenuse, and we know that hypotenuse is the longest side in a right triangle. So which means the value of sine theta will always be a proper fraction. The numerator will be less than the denominator, because it's opposite by hypotenuse. Hypotenuse in the denominator. And in a right triangle, the hypotenuse is the longest side. So the opposite side will definitely have a smaller value than the hypotenuse. So it's always a proper fraction. So any proper fraction can be the value of sine theta and cos theta. Sine theta and cos theta can take any proper fraction. It cannot take an improper fraction, because if it's 15 by 13, that means 13 is the hypotenuse. That's not possible, because this is larger than the hypotenuse. So since cos theta and sine theta can take only proper fractions, because they are opposite by hypotenuse and adjacent by hypotenuse. Tan theta is opposite by adjacent. That we can't say. Opposite by adjacent. Sometimes the opposite side can be greater or it can be smaller. So it can take both a proper and an improper fraction. Tan theta. Tan and cot. Tan and cot, because opposite by adjacent. You cannot say for sure that the legs, between the legs, you cannot say anything for sure. So tan and cot can take proper or improper fraction. But sine and cos, because opposite by hypotenuse, adjacent by hypotenuse. Hypotenuse in the denominator. So always proper. But the reciprocals, cosecant and secant, will always be improper fraction, because hypotenuse by opposite, hypotenuse by adjacent. So secant and cosecant will always represent an improper fraction. Yeah. So the idea here is to convert, meaning we have two ratios. So we're trying to have only one ratio throughout. That's why we replace tan square theta with secant square theta minus 1. You can also replace secant square theta with 1 plus tan square theta. So then after substituting that, 15 into secant square theta, 15 into minus 1. And then you know all this, you know. So secant square theta is 2. So secant theta is equal to square root of 2. At this point, you can use a right triangle. You can mark this as theta. And what is secant theta? Hypotenuse by adjacent. Secant theta is hypotenuse by adjacent. Hypotenuse by adjacent. So this also will be 1. Now you can find the other ratios. You have to evaluate this, right? You'll have to evaluate this. So what is secant theta? Secant theta is equal to hypotenuse by, secant is given, no? Oh, sorry, secant is already known. So root 2 by 1 plus cosecant, hypotenuse by opposite. Hypotenuse, root 2 by opposite is 1. So root 2 plus root 2, the whole square. Minus sine square theta, opposite by hypotenuse, 1 by root 2, the whole square. 1 by root 2, because it's sine square theta, so it will be 1 by root 2, the whole square. So that's what we have here. So once you get a ratio like this, you can immediately use a right triangle and find whatever other ratios you need. Or you can use identities like this. I've used this identity to find sine theta, and sine theta is enough because its reciprocal is cosecant. You must look at what you have to evaluate. So secant theta we already have here. Then the others are cosecant and sine. So if you find cosecant, you can find sine also. Sine, you can have cosecant. So I found only sine because its reciprocal is cosecant. Yeah. I think this we had in the test, no? This question, right? Yeah, we'll not do that now. Some of us have not taken the test. Okay, look at this one. Look at this one, children. Okay. Now this is very, very important. Very, very important. Okay. Tan theta plus cot theta is equal to 2. Tan theta plus cot theta is 2. So write tan theta plus, I'll just start. Now help me proceed. Yeah, after this. LCM. Correct. Common denominator, tan theta, tan square theta plus 1 is equal to 2. Then tan square theta plus 1 is equal to 2 tan theta. Then tan square theta minus 2 tan theta plus 1 is equal to 0. Now, how does this look like for you? Yeah, a minus b the whole square. A square minus 2ab plus b square. A square tan theta the whole square plus b square 1 square minus 2 into a into b is equal to 0. So this is nothing but tan theta minus 1 the whole square is equal to 0. Correct? So tan theta minus 1 is equal to square root of 0, which is 0. So tan theta is equal to minus 1 on the other side plus 1. So tan theta is equal to, when is it 1 in the tan table? 1.
Tan 45 degrees.
Tan 45 degrees. Tan 45 degrees. So on comparing both the sides, theta is equal to 45 degrees. So we found theta. Theta is equal to 45 degrees. But again, see here, from the equation, you can simply do it like this. What is, if it's given that tan theta plus cot theta is equal to 2, right? That means, you're saying tan theta plus cot theta, the whole square is equal to 4, huh? What's your idea after that? No, individually you can square both the sides, but separately you cannot square. You cannot square this separately, and this separately. That's incorrect. If you want, you can square both the sides. Like tan theta plus cot theta, the whole square is equal to 2 square, if you want. But no, that is not going to help us here. I was trying to say like tan 45 degrees plus cot 45 degrees is equal to 2, right? Because what's tan 45? 1. Cot 45 is also 1. What are you doing, Arjun? Table, you see. Okay, so tan 45 is 1, cot 45 is 1. So 1 plus 1 is 2. So that means theta is 45, no? You can do all this for MCQs. MCQs, you don't have to do this big working. If you have like you know that sine theta and cos theta, when it's 1 by root 2, right? 1 by root 2. So when is it 1 by root 2? Sine 45 is 1 by root 2. Cos 45 is also 1 by root 2. What is 1 by root 2 plus 1 by root 2? 2 by root 2. 2 by root 2 is nothing but into root 2 by root 2. Do it fast and tell me. 2 by root 2 into root 2 by root 2. 2 root 2 by
2, ma'am.
2. 2 or root 2? Root 2. Okay, root 2. Okay, so supposing it's given sine theta plus cos theta is equal to root 2. So you can straight away write sine 45 plus cos 45. 1 by root 2 plus 1 by root 2 is root 2. So theta is 45 degrees. Okay, but this is for MCQ. For sure, you can do it like this, but otherwise you have to show these steps. So theta is 45 degrees. Once you find theta is 45 degrees, you can now evaluate tan square theta plus cot square theta. We know theta is 45 degrees. So tan square 45, cot square 45. Because we know theta is 45. Similarly here also, we know theta is 45. Everywhere we know theta is 45. So what do you understand by tan theta to the power 7? So tan theta, the value of tan theta is 1. The whole raised to the power 7. Cot theta to the power 7. So what is cot 45? 1. The whole raised to 7. So it's always 2. We should find the value of theta and then use it here to evaluate. So this is 2, this is 2, this is 2. All right. Okay, now tell me what is the value of secant theta minus tan theta? Secant theta. Secant theta plus tan theta is 4. What is secant theta minus tan theta? Sorry? Yeah. So remember this identity, children. What is secant square theta minus tan square theta? 1. So what is this? Secant theta plus tan theta into secant theta minus tan theta is equal to 1, right? Is equal to 1. Yeah, 1. So now what is secant theta plus tan theta? 4 into secant theta minus tan theta is equal to 1. So what is secant theta minus tan theta? 1 by 4. That's what you said earlier. 1 by 4. Remember this, children. MCQ. If secant theta plus tan theta is 4, secant theta minus tan theta is 1 by 4. If cosecant theta plus cot theta, for example, I'm saying is like, say 1 by 7. Then cosecant theta minus cot theta will be 7. It's reciprocal. So, because the product of secant theta plus the product of secant theta plus tan theta and secant theta minus tan theta is 1. They're like reciprocal. Okay, when is the product 1? Only when they're reciprocals, right? 5 into 1 by 5 is 1. Okay, 2 by 5. When is the product 1? 2 by 5 into 5 by 2 is 1. 1 by 3 into 3 by 1 is 1. The product of a number and its reciprocal is 1. So we know that by the identity, we know that secant theta plus tan theta into secant theta minus tan theta is 1, because identity, secant square theta minus tan square theta is 1 identity. Yes or no, children? Okay, so secant square theta minus tan square theta is 1. All right, so you understand this? The product, so this product is always 1. That means their values have to be their reciprocals. So if this value is 4, this one has to be 1 by 4. Only then the product will be 1. If this is 2 by 3, this has to be 3 by 2. Only then the product will be 1. So MCQ. All right. But doesn't hold good for sine theta plus cos theta. If sine theta plus cos theta is something, you cannot find sine theta minus cos theta like that, because the identity is sine square theta plus cos square theta is 1. There it is not a square minus b square. Sine square theta plus cos square theta is 1. So that's a different story. We'll do it in the next class. Only for these two. Only for secant square theta minus tan square theta is equal to 1. So secant theta plus tan theta into secant theta minus tan theta is equal to 1. They are the reciprocals. So whatever is this, this will be the reciprocal of that. Similarly, cosecant square theta minus cot square theta is equal to 1. So this means cosecant theta minus cot theta into cosecant theta plus cot theta is equal to 1. Yeah. So if this is for example minus 2 by 3, then this will be minus 3 by 2. Minus 3 by 2. Minus, you should say, because minus into minus only will be plus. This will not be plus 2. It will not be plus. Sign will be minus, because minus into minus only will be plus. 2 by 3 will become 3 by 2. All right. So this sum, I have worked it in this method. See, every sum has a few ways of doing, children. I have tried my best to do the alternate method, but for every sum I have not done. But what I have done is I've given different approaches for different sums, so that you have a collection of ideas. So anything new also in the exam, you'll use one of those ideas and do it. So this is an idea here. The idea here is I've constructed two equations, because if secant theta plus tan theta is 4, secant theta minus tan theta is 1 by 4. Secant theta plus tan theta is 4 is given. So what is secant theta minus tan theta? Reciprocal 1 by 4. Now I have solved these two equations like linear equations, elimination method. I've solved it like that. Because tan theta minus tan theta will get cancelled. I've solved it like elimination, meaning solving two equations by the elimination method. And I found a secant theta. I found the secant theta. Secant theta. Then what is cos theta? The reciprocal of secant theta, which is 8 by 70. That's the procedure here. Okay, I'll share all the images. The others I've come from behind, so all this will be easy for you. The remaining, which we have not discussed in the class today, will definitely be easy for you. But remember, in such questions, remember that identity. A plus b the whole square minus a minus b the whole square is equal to 4ab. Because in most places that I've used that, see here, this one. X plus y the whole square minus x minus y the whole square is equal to 4xy. So suddenly you should not wonder how suddenly she's written this. Identity. Identity. X plus y the whole square minus x minus y the whole square is equal to 4xy. In many places you will get this. So I want to show you that somewhere I simplified and then worked. Yeah, see here, this sum. Cot theta is given, and this one is possible to simplify. No, you can take out this 2 common. You can take out 2 common and write 1 plus sine theta and 1 minus sine theta. Here also you can take out 2 common. 2 common. So that 2 and 2 will get cancelled. You can take out 2 common in the numerator and denominator. So 2 and 2 will get cancelled. Then you have 1 plus sine theta and 1 minus sine theta, which is a plus b into a minus b, a square minus b square. 1 plus cos theta and 1 minus cos theta, which is again a plus b, a minus b, a square minus b square. 1 minus sine square theta is cos square theta. 1 minus cos square theta is sine square theta. And cos square theta by sine square theta. Cos by sine is cot. So cos square theta by sine square theta is cot square theta. Now cot theta is 15 by 8. So 15 by 8 the whole square, which is this. So like this, when you can simplify this, you can simplify and then evaluate. It's not that you should substitute the values directly. You can whenever this is possible to simplify like this, I've done. No, see, this one is nothing but cot square theta. This one is nothing but cot square theta. You can simplify like this and then apply the value given. You can also do it like this. I'll share all these images on WhatsApp. All right, online students and offline students, that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you.
Thank you, ma'am.
Good night, children. Good night.
Thank you, ma'am.